Okay, so in this video we're going to talk about how to use Morpheus to generate different design concepts. So today we're going to make a different design concepts for toasting bread. So I will start by putting in my main function up here, which will just simply be toast bread. Now, before I can begin, I should have done some kind of functional decomposition. One way of doing this is to use a flow diagram. I have one right here made in PowerPoint. We have our inputs here to the left. We have energy in, bread in, and our desired toastiness level. So the functions or sub-functions that we will need is we need to somehow hold the bread. We need to heat the bread, and to heat the bread we also need to control the heat input so that we don't burn the bread. And to even provide heat to begin with, we need to supply energy somehow. Once we're done with the bread, when the bread has turned into toast, we want to dispense it, and we want to signal the user that the bread is done. So our outputs then is toast and signal. All right, so now we can move on into Morpheus. I will start by listing our sub-functions, and we had 6 of them, so I will put down all 6 of them right here. Once we have written down our sub-functions, we can start to brainstorm different sub-solutions for each of these sub-functions. So for providing energy, well, there are multiple different ways of doing this, of course. We could use electricity, wood, use gas, light from the sun. We could have some kind of a battery, and so on. And I will keep brainstorming for each of these sub-functions. Sometimes we may find sub-functions that might not necessarily need a solution. And in such cases, we could perhaps put in not applicable or manually or something like that. In this case, dispensing the toast from this contraption may not actually need some specialized solution. And so I will put down not applicable as an option to solve this sub-function. So at this point, I'm pretty happy with my sub-solutions for each sub-function. However, it may be a bit unclear what I actually mean with some of these sub-solutions. And to make my morphological matrix more clear, not just for myself, but also for my team, it may be useful to insert sketches into the matrix. So for instance, what do I mean by focus light on bread with mirrors to solve the heat bread sub-function? Well, I could put in a sketch to clarify that. So it's a good idea to have sketches for any sub-solution that is not immediately obvious how it's supposed to work. And well, if you ask me, you can't really have too many sketches. So I will put in as many as I can. At this point, I would also like to point out that the sub-solutions does not necessarily have to be physical machine elements or physical solutions. It could also be principles for how to solve different problems. So, for instance, I have the sub-function control heat input because I want to control how much heat is put into the bread. And I could do that in different ways. I could adjust the temperature. I could adjust the distance between the bread and the heat source. I could adjust if there's some kind of screening between the bread and the source of the heat. Or I could adjust the exposure time of the bread to the heat. So these are not technical solutions, but rather design principles that may be solved in many different ways. So it's a little bit more abstract. So now I'm fairly happy with my sketches. I think that my sub-solutions are clear enough. At this point, it could be a good idea to save the matrix. So to save your matrix, you can go into Import Export, and you could select Save Matrix Data. And this will download a JSON file for you, which you can later import using this button here. Have Import Matrix Data. Now then, if I go back to the Delimitations tab, we have this section here in the side menu called Design Space. This section will tell us how many possible solutions exist within this matrix. And it tells us here that the unconstrained space has 2,880 different solutions. So to create a solution, you basically take one sub-solution for each sub-function. And currently there are 2,880 different possible combinations. Now, 2,880 solutions are too many for us to handle in a typical engineering project. So we're gonna need to delimit this somehow. So to delimit the design space to a more manageable size, we have some options. The first one being to define incompatibilities. An incompatibility is when two sub-solutions cannot be combined. So for instance, we have this sub-solution, focus light on bread with mirrors to heat the bread. Now, that may not work with all of our supply energy alternatives. So for instance, it will probably not work together with gas or wood. So what I do is I click on one of them, and then I click on the one that it is incompatible with. Another example may be if we have a conveyor belt to dispense our toast, then perhaps it will not work with clamps because the clamps will attach the bread to it, and that would make it hard to release the bread without some kind of intervention. So I will actually mark those two as incompatible as well. And if we have a energy source that is not electric, then we can probably not use speakers or LED lights to signal the user when we are done. So I will mark those as incompatible as well. And I will keep doing this until I'm satisfied with all of my incompatibilities. So now I am happy with my incompatibilities. I can go back to the left here and click on the tool again to deactivate it. And now I will have a list of all my incompatibilities that I've defined here on the left. If I regret one of these incompatibilities, I can always just highlight it in the list, and I can click on the trash can icon to delete it. So now we have gone from 2,880 solutions in the unconstrained design space to 1,232 solutions in the constrained space. So we have effectively removed 1,600 solutions by just defining incompatibilities in the matrix. But there are still too many possible solutions. So we're gonna need to use some more techniques to reduce the design space. So in the next stage, we will actually go to the Solutions tab. And the Solutions tab offers us 3 strategies to deal with our solution space. The first one is the systematic strategy. And this strategy will simply combine all possible combinations. And that will result in us getting all 1,232 solutions. So if I do that quickly, we will see here that, okay, I now have a systematic solution set, and I can generate all solutions. And I will get all 1,232 solutions here. But again, that is more than we can handle, so I will remove that solution set. The next strategy I would like to discuss is the thematic strategy. The thematic strategy allows us to define a theme that we then use to delimit the design space. So perhaps I have the theme that I do not want any electric solutions. So I will put in non-electric solutions. And the definition being no sub-solutions that require electricity. So once I've defined my theme, I click Next. So we will now go through each sub-function and select all sub-solutions that are okay within the theme. So I said no electric sub-solutions. That means that wood, gas, and light from the sun are still okay, while battery and electricity is not. I then click the next sub-function, and I do the same. So in this case, all of them are okay. Move on. Okay, heat element will not work with my no electricity solutions, so I will select fire underneath bread and focus light on bread with mirrors, and so on. And I will keep doing this for all my sub-solutions. There we go. I have now applied a thematic strategy. If we go back to the delimitations tab, we can see how many solutions exist in this set. We now have 132 solutions, which is much more manageable. And once again, I can go to the solutions tab and I can click on generate all solutions to get all 132 solutions. Finally, I would like to talk about the pragmatic strategy. The pragmatic strategy asks of us to rank our subfunctions by order of importance. So I will be able to drag and drop my subfunctions here, and I will have the top priority on the top and the lowest priority on the bottom. So I will now do that for my subfunctions. So perhaps I think that the heating bread subfunction is the most important. Perhaps then we have dispense toast. Yes, that looks good. Supply energy. How we signal the user is the least important thing to me. Yeah, that looks all right. So then we have some parameters that we need to fill in. So the first one is how many solutions do we wish to aim for? So the default here is 30, a small manageable amount. We can put that even lower if we'd like, 20. We then have the minimal allowed sub-solutions per sub-function. So this strategy will disable sub-solutions, and this number here determines how many sub-solutions needs to be available after the elimination is done. And I think it's a good idea to keep it at 1, perhaps 2, but 1 is good. Then we have skew. Now, skew is a number that determines how much the lower ranked subfunctions are penalized. So a higher number here will result in more sub-solutions from the lower ranked subfunctions to be eliminated. I think 0.7, the default, is pretty good, so I will keep it there. And then I click next. Now we will go through each subfunction and disable one sub-solution at a time, starting with the lower prioritized subfunctions until we reach our target. So out of this selection, perhaps I think that the clamps are the least useful, so I will get rid of that by clicking on it. It will then jump to the next sub-function, asking me what kind of sub-solution do I want for signal user, or rather which one do I not need. I don't think we actually need this at all, so I will just remove sound from dispensing mechanism, and so on. And I will keep doing this until we have reached our target, and we can see how many are currently available right here. So once I've reached my target, it will tell me so. The targeted amount has been met. And then I click initiate. And once again, I click on generate all solutions. And now I have 18 solutions, which is a much more manageable amount of sub-solutions. And we can click them here to go through them. At this stage, it might once again be a good idea to save your progress. So go to import export, click save matrix data, so you do not lose any of your progress in case something happens. So now we have generated our combinations. However, at this stage, they are merely combinations of different ideas, different design principles. We need to do something else to have these qualify as proper concepts. We need to define them somehow. So what I can do is I can click on a concept, and if I hover over it, there is this button here with a pen on it, which we can click on, which opens up this view where we can look at this combination in particular. In this view, we are allowed to write a description of our solution. And we can also attach a sketch to make it even clearer. Unless you have way too many solutions, I recommend sketching all of them. So for instance, we have in this case, we want to heat the bread by focusing light on the bread using mirrors. We don't want any specific solution for dispensing the toast. We want our energy to come from light from the sun. We want the bread to be held in place by a skewer. We want to control our heat input by adjusting the distance to the heat source, and we don't care about signaling when it's done to the user. So I can start by writing a description. So in this case, the bread is held in place using a skewer, which is mounted on the center of a mirror parabola. The bread can be placed higher or lower on the skewer to adjust the heat input. The parabola is then aimed at the sun, which will commence the toasting process. And to make this clearer for myself, if I open up this solution in the future, and also to my teammates who may have no clue what I mean by this solution, I can make it much more clear to them by adding a sketch. So here I have my parabola, here I have my skewer, and on the skewer I have my toast, right? Then I click Save. And now we will get this small green checkbox on that solution telling us that we have defined it properly. And we can then do that for all of our solutions. And once we are done with that, we can click on this Open Concept Catalog button, which gives us a list of all of our solutions, along with the description of the solution and the sketches of the solutions. We may also want to export an image of our matrix, or even export the results to a CSV file for processing in some other software. We can also export our concept catalog by clicking on the Export Solutions to PDF button, which can also be found in the concept catalog itself. Here, export as PDF, and that will give us this list in a separate document. And then we are done with learning the basic functionality of Morpheus.